Hello everyone. In this video, I'll be talking about large language models, which is a part of artificial intelligence, which is basically a generative AI project. So, large language model or LLM is basically designed by neural networks, and it is based on a model called transformer model. Now, in the later part of the video, I have shown how to implement a LLM project or generative AI project by using Python codes, by writing Python codes rather, to showcase or to make you people understand how to implement a LLM model. Now, what is LLM or large language models? Now, in LLM model, you will get the generation of the replies from the machine itself after it is being fed up with the after you feed the machine rather with a massive sets of languages or questions. So this is the basic idea of the text generation or generative AI projects, and LLM is one big example of that. In today's world, you see the chat GPT is taking the world, and chat GPT is based on this LLM model, and which is again based on the transformer model. Now in the later part of the video, we will discover how to implement the LLM project, and you will understand how to write the Python codes for implementation of the LLM projects. So let's discover that in the later part of the next part of the video. So coding a large language model LLM from scratch is a complex and resource intensive task typically undertaken by large research labs and organizations with significant computational resources. However, understanding the basic steps involved can provide valuable insight. So here's a high-level overview of how to code a large language model using a transformer-based architecture like GPT, that is generative pre-trained transformer, as an example. So I'm gonna write the codes for this. Actually, I'm gonna exemplify how to code basic large language model from scratch. Okay, and there are several steps for that. Before that, let's go to the terminal. So you can see this right in the screen. Okay. Now, as we all know that we will write the codes on Jupyter Notebook. So let's write the command the Jupyter Notebook, and let's go to the terminal, go to the Jupyter Notebook interface. Okay. So as I have hit the enter button, so it's already automatically it's automatically redirected rather to the Jupyter Notebook interface like this, as you can see in the screen. So here I'm gonna use the most basic kernel, that is IPy kernel, that is Python 3 kernel, and I'm gonna write the codes. Okay. Now before getting into the detailed coding, let's talk about the steps to code a large language model. So there are actually several steps for coding the large language model. To be precise, it will be around 6 steps, which are firstly setting up the environment, and after setting the environment, we will be defining the model architecture, then we'll be preparing the data, and after that the next step is the training the model, then the next step is fine tuning, and the last one is basically evaluation and interference. So these are the steps of implementing the large language model. Okay, so let's write the code one by one. So in this, the first thing is that we'll be setting up the environment. We'll be setting up the environment, and we'll write the further we'll have to write the code. So here we have to ensure that we have the necessary libraries and tools installed in our system, such as PyTorch or TensorFlow in an environment actually, or for deep learning and Hugging Faces transformers library for pre-built models and utilities. So I'm gonna the model is basically here. The large language model will be implementing using a transformer based architecture like GPT, and the example is this. So for that, for the libraries, we have to install some required for setting up the environment. Rather, we have to install some libraries like Python and then other transformers. Okay. Let's write. So firstly, we'll be setting up the environment. So the first step is basically setting up the environment. Okay. So for that we have to check the which library. The library is installed in our system, that is Python. So let's write like this. Python is there. You have to write the pip install torch transformers. Yeah, so this is the we have to check it out. If it is not installed, so we have to just install it will install by writing this command, this pip install torch transformers. Okay, yeah. Now this is the first step. Okay. Now the second step will be defining the model architecture. So here we are gonna use more precisely transformer based architecture. So let's define the model architecture. We have to define the model architecture by writing these codes, including the encoder and decoder blocks. Now transformers use self attention mechanisms to process input sequences. Now let's write the Python codes. For that, let's mention here. So we are defining the model architecture. So let's mention here So let's define the model architecture. Okay, yeah. Now for that we have to write the codes. We have to import torch So we are importing torch.nn as nn. So we have to import torch, and then you have to import torch.nn. So as nn. Okay. Now from transformers, from transformers So from transformers import import or we are gonna import the GPT-2 config and GPT-2 model. GPT-2 config and GPT-2 model. We are basically importing by writing this. Okay, so this is how we are defining the model architecture. And so what we have done here, basically we have imported the torch, then we are importing torch.nn as nn. Then from transformers we are importing GPT-2 config and GPT-2 model, right? Now let's write the next code like this. So in our class transformer model nn.module. So now class transformers model nn.module. Model module. Colon. Okay. Now, so this is the class transformer model. Now then, basically this is the nn module. Now then, let's write the next code. div underscore init underscore self vocab size vocab size hidden site. So now this is hidden sites. Number blades, number of heads, well, so this is number of hits. Yeah, now the next part is super transform model self hits super transformer model comma self transformer model. So this is super transformer model. Transformer model. Okay. So this is stop. Init. Super transformer model. Well, now the next code is self.configuration. Nice. So this is self.config. Then this must be equal to so this is self.config equals gpt2 config, then vocab size and embedded these things. Okay. So self configuration or self config equals GPT-2 config then vocab size equals vocab size in embedded equals hidden layers. There is number of actually hidden sides. There is hidden layer, number of hidden layers actually, hidden size actually. Then number of layers, number of layer actually equals layers. Layers. Okay. Yeah. Then number of head equals number of heads, n heads. Heads. In head equals number of heads. Then self transformer equals GPT-2 model self dot config. Okay. Yeah, so this is the self transformer. Then by default okay, the next code I'll be writing here after erasing this code, but my note that the next code will be just in continuation with this one. Okay. Default forward self input ID is actually okay. Then so this is input ID. Then outputs, the outputs will be the outputs equals actually self dot transformer input these input IDs. Okay, yeah, that is really important. Now return outputs last hidden state. Okay, and the next part will be the preparation of the data. Okay, yeah, return outputs dot last hidden state. So now the next part is the preparation of the data. Okay, so let's try the code for preparing the data. Okay, you can see the screen, so I will write the code here. Now for that we have to collect a large data and diverse data set of text, then tokenize the text using a tokenizer compatible with our model. Okay, so for that let's write the code. Python is actually Python code. So now from transformers input from transformers the code is like that. From import GPT to tokenizer. Now tokenizer equals GPT-2 tokenizer from pre-trained GPT-2. Okay, pre-trained GPT-2. Yes, pre-trained GPT-2. So that's the oh sorry, it should be within the brackets. It's not because we're calling that. So it should be this. Yeah, it will be small lettered actually. Okay, so then the data set equals now your large data set of text. That has to be the case. Okay, so it should be uh, it should be your uh, large data set of text. Large of text. Okay, yes. So now so this is the data set. Now default tokenized data default tokenized data data set this should be colon yes oh sorry so this is the def function. So for data set after data set you have to just call the data set that I've called here. Then you have to write this def function. So this is a def tokenized data set. That's the idea. Yes. Then I have to return tokenizer encode text, tensors, pt. Okay, so that part. So now I'm just going to erase this part of the code, but note that all are just in continuation. I'm just writing it here. Okay, yeah. So okay, so that's the idea. Now then tokenized data. Data set. Okay, so this is all about the preparing the data, these codes for that. Now the next part of our code is that we have to train the model that we have already created. So training the model is the next destination. So let's write the code for training the model. So for that, let's erase this one, but remember all those are just the continuation of this code. Okay, so this is the training the model. So this is training the model. Now for training the model, we have to set up the training loop, including the optimizer and loss function. We have to train the model on our data set. Okay, so all must be on Python. Yeah. Now for that, model equals transformers. Okay, transformer model. Okay, then vocab size dot vocab so this is now training the model. As you can see in the screen, they've already written the code. The model transform model vocab size tokenizer at vocab size hidden number layers actually. So this is hidden layer. Hidden size equals 768. Number of layers and number of heads both at 12. So let's write it down. So number of layers and number of heads both are 12 here. And then optimizer equals torch dot optim dot Adam W model okay. IR okay. So this is that criteria NN dot cross entropy loss function. So that is I already explained it. After that, for epoch in range epochs for input IDs in data
for input IDs and data, then optimizer dot zero.
Underscore grad. Well, this is optimizer dot zero underscore grad. Now, outputs. Outputs equals models. So this is input IDs. Okay. Well, so the next part is, okay, so before going to the next part, let's erase this part. I mean, just for ease actually in writing, this nothing else. But note that these are all these are in continuation with the next ones. So okay, so this is the input IDs, rather outputs. Then let's go to the loss function. I mean loss. Okay, so this is loss. You have to mention this loss function as well. Loss. It is actually criterion, and it must be outputs model. So it's the then input IDs yeah, so this is the input IDs dot view So this is input IDs.view. Then lost dot backward actually. Yeah. Oh, okay, fine. So now let's print epoch loss so this is and then for that just when for ease in I'm just erasing these codes, but all these are in continuation. So train tokenized data three. Okay, so this is the after tokenization. So this is a train. Now the next part is so this is the training the model. So we have trained the model now. Now I'm erasing the data. Now the next part will be fine tuning. So this is fine tuning. So this part is fine tuning. So fine tune we have to fine tune the pre-trained model on a specific task or data set to improve its performance for that particular application. Now the codes will be written in Python, so let's write the Python. Okay, and the next part is we have to write the code for that. So for that, let's write from transformers. From transformers, we have to import the trainer. We have to import the trainer and training arguments. Now, training arguments. So for abbreviation, I'm just writing as ARGS. Okay, I have to put underscore here. Yeah, so this is training arguments. So this is training arguments. So this is training arguments. Yeah. To go to the output directory. It should be results. Now, number of trained epochs equals 3. So before that, per device so per device train batch size equals 4. Now save steps. Equals 10 underscore 000 save total limit equals 2. Okay, so now it should be closed. Yeah. Okay, now the next part will be the trainer equals trainer model equals model So now for ease, I'm just erasing some parts here just to for my ease, and then let's write. So this is model arguments equals training arguments Yeah, so this is trainer model, then arguments, training arguments. Now I have to call the train data. I have to call it train data set. Okay, this is train data set. Okay, so this is tokenized data. Then trainer.train. Okay.
So that's all about the fine tuning of the pre-trained model on a specific task or the data set or data set actually, for improvement of its performance for the particular application. Okay, now the final one is the evaluation and inference. So the final part is the evaluation. Okay, for that let me erase these codes and let's write it again, and let the next part rather. Evaluation and inference. Evaluation and inference. Okay. Anyway, so let's begin writing the code. Now the final part, this is the final part of the coding. So here we will evaluate the model's performance on a validation set and use it for inference. Okay, and the code will be written in the Python rather. For that, model dot evaluation so test sentence equals once upon a time. Okay, once upon a time. Input IDs equals tokenizer dot encode test sentence then return tensors yeah. So this is the return tensors equals pt. Now output equals model input IDs. So output equals model and then input IDs. Now the next one is, let's predict that then there is a predicted text
predicted text equals tokenizer dot decode output zero skip special tokens. Skip special tokens equals true. Okay. Equals true. Print predicted text. Predicted text. So okay, so that's the evaluation. Yeah. So that's all about the evaluation interference. That's the code. Okay. So this is how you need to implement the large language model that I have just shown thoroughly in this code. I hope you have learned how to code a large language model. These are the steps. That is, you have to first set up the environment, then you have to define the model architecture, then you have to prepare the data, then you need to train the model rather, then fine tune the pre-trained model, and at last you have to evaluate and infer this LLM. So that's all I hope you have learned from this video. Let's meet in the next video. So in this video, I have explained how to, I've explained rather the large language models and the generative AI projects. Also, I have shown how to implement the LLM model by writing the Python codes thoroughly, step by step. I hope you have understood the step-by-step approach of implementing the LLM model by writing the Python codes. So that's it in this video. Let's meet in the next video.